In previous session, we have discussed about deterministic experiment, the random experiment, classical approach, and axiomatic approach to probability. And we have discussed about the sample space and the event, the meaning of the term event. So there are several terms related to this term event, and we have already we have studied about the probability of an event, the limit of the probability of an event, and it always lies between 0 to 1. Okay. So on the basis of this, how many types of events are there? So there are several types of different types of events. Some of them we will discuss today, which will help you to solve the several questions of probability. Like first type of event is impossible event or the impossible event. Okay. So what is the meaning of impossible event? So the event, the occurrence of whose is not possible. Event whose occurrence is not possible is called an impossible event. For example, if the sample space is throwing a die, so we know that there are 6 events associated with this experiment, occurrence of 1 or 2 or 3 or 4 or 5 or 6. Now, if we say find the probability of getting a number greater than 6, so is it a possible event or an impossible event? Event of occurrence of a number greater than 6. Can you get that in throwing a die?
No, sir.
Means it is a type of impossible event. Okay. The event whose occurrence is not possible. The event associated with an experiment means associated with a sample space. Understood? The event associated with a sample space whose occurrence is not possible is called an impossible event. Okay. The event associated with a sample space means with a random experiment, okay, whose occurrence is not possible is called an impossible event. The event associated with a sample space whose occurrence is not possible is called an impossible event. Okay. Learn all these definitions. For example, if sample space S equals to, we have discussed an example early, event of throwing a die. Again, if we discuss another sample space, event of throwing event of throwing or tossing, actually, 3 coins. Event of tossing, 3 coins. That is HHH. We always write the sample space according to set theory. HTH, THH, HTT, THT, TTH, TTT. So the total number of event in this is 1, 2, 3, 4, 5, 6, 7, 8. Is 8. Now E equals to, if it is given that event of getting 4 heads. So can you get 4 heads? So there will be no outcomes related to it. Means number of element in E will be 0. So its probability also will be, what will be the probability? It is 0. Means probability of an impossible event is always 0. Is that clear to you?
Yes, sir.
Probability of an
Yes, sir.
impossible event is always 0. Okay. The probability of an impossible event is always 0. Okay. So write the second type of event. It is called sure event. Sure event means it is just opposite to impossible event. The event associated with a sample space whose occurrence is always possible. The event associated with a sample space means event associated with a random experiment. Sample space can be drawn only to a random experiment, or the probabilistic experiment. So an event associated with a sample space means we are discussing only the random experiment. The event associated with a sample space whose occurrence is always possible is called a sure event. Understood? Whenever you perform an experiment, that experiment is called random experiment. Like tossing a coin or throwing a die, etc. Now, if we say occurrence of a number in throwing a die, occurrence, what will be the event of occurrence of a number between 1 to 6 including both? So it is always a sure event. Understood? The event associated with the sample space whose occurrence is always possible is called a sure event. Okay, now I am not writing the definition. Write it yourself. I will write only the example. Okay. The event associated with a sample space whose occurrence is always possible is called a sure event. Written, everyone? The event written. The event
Yes, sir.
associated with a sample space whose occurrence is always possible is called sure event. For example, if sample space S equals to event of showing event of showing a die, okay, E equals to event of occurrence of a natural number less than 7. So if you find the simple space S, it is 1, 2, 3, 4, 5, 6. And the set of favorable outcomes, 1 is less than 7 and is a natural number. 2 is also less than 7, 3, 4, 5, 6. All are less than 7 and are natural numbers. It means number of elements in E means number of favorable outcomes become equal to the total number of outcomes. Now, if we find the probability of this sure event, it will be NE by NS. That is, NE is equal to NS, so NS upon NS. So probability of a sure event is always 1. Is that clear to you? Probability of sure event is always 1. Okay.
Yes, sir.
Write in your notebook. After understanding the meaning of event, impossible event, sure event, let's now discuss the most important type of event is called elementary event. Okay. Elementary event. We are discussing it in our language, which is easier to understand, though these all are given in your book also. Now, जैसे first we will discuss the example. If we discuss S equals to event of throwing a die, है ना? So there are 6 different events associated with it. If we write them separately, then each of the event associated with this random experiment, yeah, or we say associated with a sample space, is called an elementary event. For example, in throwing a die, E equals to event of, if we write event of occurrence of 1, so it is the pure event. It is the most simplified event. Understood? So these types of events are called elementary events. Understood? They cannot be further simplified. They are the simplest form of event, and actually they are the outcome, single outcome associated with a sample space. Understood? So we can say each of the outcomes associated with a random experiment or a sample space is called an elementary event. Understood? These are the simplest form of events. Okay? Understood?
Yes, sir.
Each of the outcomes, write the definition. Each of the outcomes associated with a random experiment. Okay? Associated with a random experiment each of the outcomes associated with a random experiment, or we can say, or a sample space. Each of the outcomes associated with a random experiment are called elementary events. Understood? For example, if we say the sample space, first always we will discuss the sample space. S equals to event of throwing a die. Event of throwing a die. And write E1 equals to event of getting 1 in throwing a die. So it's an elementary event. Understood? Sample space is 1, 2, 3, 4, 5, 6 set. But E1 contains only 1. Or if we write E2 equals to similar event of getting 2 in throwing a die. So it only has one outcome, single outcome. It is the simplest form of event. Understood? Event of getting 2 in throwing a die. Written? Event of getting 2, etc. So there will be 6 elementary events associated with this event of throwing a die. है ना? Sample space is event of throwing a die, and there are 6 elementary events associated with this. Means they cannot be further simplified, we can say. Again, elementary events cannot be further simplified. Okay, write one more line. Note, elementary events cannot be further simplified or decomposed. So they are also called indecomposable events. Understood? Indecomposable events. Okay. The elementary events cannot be further simplified or decomposed. That's why they are also called indecomposable events. Now the next type of events are compound events. Compound events. Clearly, they are obtained by combining 2 or more than 2 elementary events. Understood? For example, if we say in the same sample space of throwing a die, if S is the sample space, that event of throwing a die. First listen the example, then I will tell you the definition again. And if we write E1 equals to an event that event of getting an even natural number. Okay. Now can you form this set? Huh? I'm writing the sample space 1, 2, 3, 4, 5, 6. And what will be the event of getting an even natural number in throwing a die? Can you tell?
So 2, 4, and 6.
Yes. 2, 4, and 6 means this is obtained by combining two or more than two elementary events. Agree? So these types of events are called compound events. Understood? The events which are obtained by combining two or more than two elementary events are called compound events. Okay? Write the definition and then example. The events which are obtained by combining two or more than two elementary events are called compound events. Similarly, we can form some more compound events also associated with the same experiment, like E2 equals to, if we write event of getting a number multiple of 3, getting a multiple of 3, okay, in throwing a die. In throwing a die. So, what are the events? 3, 6. So, it is also obtained by combining two elementary events. Understood? So, these compounds events are also called decomposable event. Understood? Compound events are also called decomposable events. Written, everyone?
Yes, sir.
So now we write the next type of event. Before we write the next type of event, there is one most important type of an event. We can say it as the negation of an event. Okay. Compound event is the fourth type of event. So now we'll discuss negation of an event. Negation of an event means the event which is just opposite to a favorable event. Negation of an event. The event which cannot occur when an event occurs. If we define it in terms of a given event, capital A, okay? If capital A is an event, okay? Then the event which occurs when A doesn't occur is called negation of the event A. Understood? The negation of an event A is defined as negation of an event A is defined as the event which occurs only when the event A does not occur. Okay. Negation of an event A is defined as the negation of an event A. How will you define it? Negation of an event A is defined as an event.
The event that occurs when A does not occur.
An event which occurs when, and we can say by emphasizing it, when and only when. When and only when A does not occur. It is denoted by A bar. A bar. Okay. It is denoted by A bar. Clearly, A bar means sample space difference A. Okay. So number of elements in A bar is obtained when we subtract number of elements in A from the number of elements in sample space. No bar on S. So if we find the probability of not A, we call it probability of not A. It will be number of elements in A bar upon number of elements in S. That is, now number of elements in A bar we already have calculated. Number of elements in S minus number of elements in A upon number of elements in S. That is, number of elements in S upon number of elements in S minus number of elements in A upon number of elements in S. That is 1 minus, and we call this as probability of A. So probability of not A equals to 1 minus probability of A. Understood? Write this also in your notebook. In the axiomatic approach, we can define like negation of an event. Have you understood negation of an event? Similarly,
Yes, sir.
union of two events. Union of two events. In set theory, we have studied about the union. It is denoted by U, na? And union of two events A and B means the event of occurrence of either A or occurrence of either B. Understood? The event of occurrence of either A or B is called the occurrence of A union B. Understood? Event of occurrence of either an event A or an event B is called occurrence of event A or B, denoted by A union B. A union B means either A or B. Okay. And its probability A union B is given by a formula, probability of A plus probability of B minus probability of A intersection B. We all know this. And other thing is intersection. In intersection of two events. In place of or, we write and. Like this A intersection B. Okay. Means event of occurrence of an event A and event B simultaneously is called A intersection B. Okay. A intersection B means event of occurrence of an event A and B. We will further discuss about this union and intersection in next session. Okay.